opportunity to be a part of this enlightened session on mechanistic and non-mechanistic science discussions. And I would try my little bit to speak a few words from what I understood from chapter 6 of this wonderful book by Richard L. Thompson, also called Sadhaputta Prabhu. Let me share my screen.
Can you turn off the entry time?
Please, can someone let me know if you can see my screen?
Yes, we can see it.
I'm on the wrong slide, directly taking you to the conclusion. All right, get started, I believe. So this is a very interesting chapter, and I would say this is kind of a bridge between the previous chapters and the next future chapters that's going to come up in this book. And here Richard L. Thompson takes from purely from a scientific perspective that he was talking about and dwelling on in the previous chapters, and then he's going to introduce the theology to some extent and comparisons with the scientific paradigm of Bhagavad Gita in this chapter. And then he's going to, the future chapters, he's going to draw a lot from this Bhagavad Gita. So this is going to be a very wonderful bridge chapter, I would say, and makes a very interesting reading. So the topic mainly dwells on the modern approach of science in things concerning the Mother Nature and how it works, and everything concerned about the laws that governs it. So so in the early 19th century and also much part of the 18th century, a lot of discoveries are made in terms of finding the basic laws of nature, how it works, physics, chemistry, and other natural sciences. A lot of progress was made in terms of understanding how things work to some extent. And it's still an ongoing process. It's a never-ending process, actually speaking. And but a lot of great grounds were covered in the 2 centuries, 200 years that we're talking about. And so the scientists were, if I can say, were a little more greedy to kind of come upon something like a unified theory, which would possibly explain everything in mathematical terms. That would be something like a very simple-looking formula that can explain all the natural phenomena going all around the world. And so that's the quest for that unified theory was so intense that everybody was looking forward for it. So starting with Newton's laws, which kind of explain a lot about the how the world is moving, and then there's a lot of progress made in thermodynamics and so many things which helped us to understanding how an engine works and how it can be used to generate power to drive cars, for example, or rockets. So that's, yes.
I'm sorry to interrupt. Is it possible you can make your screen without the presenter slides, just so we can see the main slide as what takes up the full screen?
Okay.
Maybe under display settings, because we're seeing the next slide and also your notes on the side.
Oh, I see. Okay. I think what is happening is let me.
Yeah, you probably have to unshare it and then reshare.
Sorry.
Yeah, so yeah, unshare and then start the slideshow and then reshare and only share the screen where the slide takes up the whole screen.
But I think he's done that.
Oh, okay, that's.
And then in that case, then I don't know.
I
Yeah.
think,
No,
this is fine now.
Yeah,
This is better.
Yeah.
I mean, that's, I know what you're talking about, but he's close to it.
Okay.
Yeah, this is
Yeah.
good. Thank you. Now we can see just that one slide with the others on the,
That's good.
thank you.
Thank you. So yes, so there's a lot of progress made, which kind of helped scientists to uncover a lot of different things and help the engineering mind to make different things that would bring a lot of comfort in our life, like the cars, the rockets, and things like that. And that the quest for the unified theory continued. And of course, the Newton's laws of gravitation and the basic mechanics was not sufficient to explain a lot of things. So we had to, the scientists had some other theories to explain things like nuclear forces, electricity and magnetism, so on and so forth. And some of them were quite close and in explaining the phenomena. So, but that was still not close enough. So still the search continued. And so the unified theory was still elusive. And there was a lot of proposals from the subatomic world, which also called as quantum mechanics. So they had a lot of proposals to bridge the gap. A lot of them fetched Nobel's Prize as well, like the work on quarks and leptons. So they were all pretty pathbreaking to some good extent. And there are a lot of scientists like relativity theory proposed by Einstein, and so many great other scientists as well. So kind of really made a lot of different proposals and hypotheses to bridge the gap. But it is still elusive. The search continues even into the 21st century, and also it will continue further as well. So that is a quest that the scientists have always been working towards. And but so Richard Thompson, also called Father Portugal. So his view on that was pretty to some extent critical, in the sense, although you are making progress towards something called unified theory, but you're leaving behind a lot of things unexplained, even in the basic explanations. So everything works to some extent to an acceptable range. For example, what is the acceleration due to gravity? It's 9.8 meters per second square. So it's when everybody does the experiment in their school, so they will all come within a certain range from say 9.879 to 9.84 and all the way to 9.9. So there's a range of values that comes. So that goes on explained. So he wants to give credibility to that range as well. So nobody should just ignore it like that. And he brings forth that. So that's where this question of chance comes in. So the scientist, it's a general approach in science that you want to explain a certain thing. You always start with some assumptions. So Schrodinger's equation, you can start with some assumptions. They will say, here is a reference frame, this is so and so, and assuming this is like that, this is like that. Then we can start our trying to explain a few things. Then they come with some equations. So this assumptions and the restricting the reference frame to a certain thing has always been there in science. And this he calls it as a reductionistic approach. This reductionistic approach is pretty common in science, so common that without that it's difficult to explain a lot of the different things that's going on. And so the pros and cons of it is that the good part of it is that it helps in explaining a certain phenomenon within a certain very conservative framework, whereas it is kind of giving living through a lot of different unexplainable, although it can be and greatly, and although it's not in very minority observations, if I can say that. It's although may not be a significant number, but still there are a lot of questions to be answered. And so reductionist approach is also the main drawing force behind the unified theory. So everybody is hoping that they can come up with that the God formula, which would explain anything and everything that's happening in this world. So that is a reductionistic approach that he's pretty critical about. And whatever is not really not able to fit into the reductionistic approach is all the exceptions are we can possibly put under another explanation called as chance. So this whole chapter is about chance and unity of nature. So the reason is that it's the reason or the drive behind this unified theory is that it has been the approach of humans from the time of Renaissance that everything needs to be in a way explainable to the human mind, either in terms of a formula or in terms of some mathematical approach towards certain things. So there is a kind of an approach in the humans that it has to be understandable. It's not possibly non-explainable. It has to be explainable to a good degree. So that is the approach that has been, and because otherwise we'll have to give room for something that is not explainable, which you have to bring some divine intervention, which they want to avoid at all costs. So that brings to the point of, and in order to accommodate that unexplainable or the minority exceptional observations, they bring in the chance theory. So this chance theory is used pretty, it goes in different languages at different times. Could be assumptions, could be, it could be even be chance when you come to evolution and so many things, everything happened by a pure chance. Or even if you go to how the universe was created, so it's all different approaches are explained, but it's all purely imaginative and purely given to the chance factor. It gives a lot of weightage on the chance factor. So it so happened that this happened like this, and this how it finally ended up. So that is something that Sadhguru was pretty critical about, and he goes on to explain a few case studies in order to kind of explain this much further, in a language that we can understand, in a context that we can understand. So first of it is he talks about this wonderful square monitor that we are all used of in our times of cathode ray tubes. So you have monitors which display things, and it's all. So it's either so in this particular case, this cathode ray tube TV displays a 1 or a 0, and that changes every second. And so that is this model. So what happened is that every second it's going to crank out either 1 or a 0. And it's a purely a random process, meaning to say that no prediction can be made on what is coming up next. Just because it was 1 this time, it doesn't have to be 1 again, or doesn't have to be 0 again. So it's a purely random process. So that's the history of this machine would be to just keep on cranking out 1s and 0s over time and every second. So it's going to end up like something like a sequence of 1s and 0s. The sequence of 1s and 0s is going to so it's over a period of time when you see what's the output sequence of 1s and 0s, then you're going to see that. So you would expect that there'll be, since it's a random process, it has to be 50% 1s and 50% 0s. Even mathematically speaking, and that is only possible when you have an infinite sample of numbers. When you have an infinite sample of numbers, you're going to have 50% ones, 50% zeros. That is the probabilistic theory. Because a purely random process, it has to have equal chance for a 1 and a 0. So considering that over a period of infinity, it's got to be 51, 50% 1, 50% of zeros. And when you take a finite number, say 979 in this case, that apparently he wrote a program to crank out this different numbers in a random fashion. And you collect about 1,000 different numbers of ones and zeros. And he observed that it's about 46.8% 1. And in another trial, he found it as 53.2%. So sometimes it's below 50, and sometimes it's above 50. So that's what happens when you have finite numbers. That's the explanation that we would like to offer. But what the problem with this approach is that, again, a lot of assumptions is being made about this being a random process. And we're trying to force a theory that it has to be 50% ones, 50% zeros, right? An infinite process. Since nobody lives up to infinity to really see that result, so we kind of accept for a fact that yes, this is going to be a statistical process, purely random process. It's called 50-50. But there is no effort that is put on to explain or give some credibility to these numbers, 46.8 to 53.2. This range is acceptable if you want to give into some, throw out some exceptions and just take it that it is pretty averages up to 50. So it is to some extent that you can deduce it that way if you want to, but it is not really a purely scientific process. So you need to have an explanation of why it is 46.8 and why it's 53.2. Why the same trial when done with first time it was this, second time it was this. So we kind of cut corners to kind of give explanations and make it known that this is how this works. So that is an approach that we have seen pretty common in science. So that he's just drawing your attention to that process in this very simple example. And another example that he gives us from this. So I don't know if I'm spelling it right. Gauge counter. So this is supposed to be a counter which captures all the particles that is emitted out of a radioactive reaction. So alpha particles, they are helium ions, beta particles are electrons, gamma rays are photons. It's with high energy. So the counter is going to capture every time there is a reaction. There is always an after effect of either alpha, beta, or gamma, which is all going to be recorded in this Gauge counter. So this, again, a similar machine is constructed here, which is going to keep counting. And this counter is going to have keep a count on how many recorded radiation happens. And based on that, you're going to also kind of deduce how much radioactive atoms are still remaining because they are continuously undergoing radioactive decay. So what happens? The usual explanation is that in every second, if you were to take the sample, if there is a radioactive decay or not. So if there is radiation decay, then you mark it as a 1. If there is no decay, then mark it as a 0. So that's the stochastic model that is proposed here. So in this case, what happens is that so that is an approach that we usually observe that the radioactive decay follows this law of exponential decay. And it's usually measured by half-lives because it's not ever going to be fully decayed. The decay is going to go for infinity, the exponentially decaying curve. And all you can talk about is half-life. Half-life is when the half of the atoms is going to be, the radioactive atoms is going to decay into a non-radioactive isotope. So that is the problem that is under consideration here. So we, out of observation, repeatedly, we see that it's pretty closely following an exponentially decay curve. So it's expressed here as nt, or number of atoms at the time t is n0, or the initial number of atoms in n0, and it's exponentially decays by e power minus lambda t. And so this process, stochastic process, so if you were to keep a window of 1 second and keep seeing if there is a decay or not, then you might be tempted to propose that it's an equally random process, and you might get a 1, you might get a 0. So that's, but it's not very difficult to find out that if you want to find how much atoms decay in a given time frame, a period, you can always find out that by using this formula of nt is equal to n0 into e power minus lambda t between t2 and t1. So you can always do integration. You can find out between t2 and t1 what is the number of atoms. So that is possible. So, but you can possibly change this decay law and make it a linear decay relationship by possibly by different factors. You can do either you can absorb the subatomic particles that's getting emitted, like the alpha, beta, and gamma. That way, the number of counts is reduced. Or you can introduce a way to increase the number of atoms in the real time. So that way you can possibly control the whole equation to bring it down to a linear equation. So which means that there's a linear decay, and it's going to decay in a linear fashion, just like a straight line in a two-dimensional graph. So that is possible. So the point that he's trying to make is that, so we don't exactly know how do we come to this equation, but all we know is we do not know if there is behind the screens there are some other things that's happening. But this is a larger observation that is seen over different experiments, and so we come to conclusion that this works like this. But we may not be giving a lot of there could be many other things that we're missing. That is the point that he's trying to bring here. And here, so he comes to the point of he concludes that from these two experiments that there is a determinism, there is an absolute chance. Determinism aspect of any experiment or any phenomena that we see in nature is the explainable part, where you can come up with a theory and subsequently a mathematical formula or an explanation which explains how what is the nature of certain phenomena. Force equal mass into acceleration, for example. So you give a force, and there is a change in the motion that can also be observed. So to a large extent, it follows this particular deterministic path of a mathematical relationship. And there are a few things that possibly is not fitting into that explanation, which can be given to the absolute chance. And this absolute chance is the things that could be anything from assumptions that we begin with, or it could be anything that helps us in providing some explanation to explain the exception that we observe. So it's pretty open-ended here. So this is an usual approach that we have in terms of scientific explanation of different things that happens. So he concludes that when some scientists view a natural phenomena in the actual universe, it's obeying such combined deterministic and statistical laws. They show strong tendency to suppose that phenomena are governed by these laws. And whatever is not explainable by these laws, they conclude it to be an absolute chance. So then he comes to the point of quantum theory. So where he says that this quantum mechanics and quantum theory helps a lot in kind of filling the gap in terms of explaining the absolute chance. Everything that is not explainable in the realistic world can be relegated to the quantum world, where you may possibly have an explanation. So that's just important point that he makes. That's how he sums up the traditional scientific approach that people have been taking. Then he comes to the absolute chance. So when he says that this leads naturally to an idea that one may consider a theoretical description of phenomena complete as long as it is thoroughly, sorry about that. Am I audible?
Yes.
Okay. So and then he says that this lot of random sequence of events, in other words, sequences satisfying the statistical criteria of randomness, these sequences must be products of causeless chance. However, this is not complete, as well as determinism and absolute chance cannot make things real like humans as a byproduct of evolution. And he dwells into this evolution quite a bit here. Then he explains how, even if you have to repeat the experiment of how did the humans come into existence through the evolution process, you're definitely not going to arrive at the same kind of humans. And since there's absolute chance that it so happened that all the unicellular organisms all evolved to become complex organisms, then finally evolved to become humans, it's a product of absolute chance. So that's a very weak explanation. So that's what he says, that it's a pretty weak explanation. And if you had to repeat the experiment, it's never going to happen in a laboratory setting. So that's where this absolute chance is a pretty weak explanation, and it's rather an escape route for anybody who doesn't want to go into the determinism. And so that's where so he brings in this concept of this is possibly the unity and diversity as an explanation. And so that's what he's going to dwell upon the next few slides. I will talk about that. So this unity is what everybody wants to stress upon. So we talk about humans, and we have a very interesting explanation even in Mahabharata. Yudhishthira is saying that ahara nidra bhayamaithanam samanya etat purushat naranam. So there is a lot of common things between humans and all the other living entities. That is eating, sleeping, mating, and defending. It's pretty much common. So you're going to kind of sum up all living entities into this 4 activities. And you can also do it with humans. But as we know, as humans, everybody's do not like to be summed up like that. They're all going to be pissed off. You're going to say, this is what makes a human. Then no, nobody's going to accept that. Everybody knows they have some unique feelings, feelings about certain things. They have some dislike experiences, which they do not want to just be shrugged off. And they know people are known for their character. They're known for their views that they have towards the world. That is what is the defining or the differentiating factor between humans. So nobody likes to be just summed up into one common model. Everybody fits. This fits everybody. Everybody fits into this kind of explanation. So similarly, this diversity is something that is very important, and it has to be acknowledged. This diversity is there. The nature also, if you can see the wave patterns, also the leaves and the fractals. Fractals is a very interesting phenomenon. You can see the nature, where at the microscopic level and the macroscopic level, you will have the same patterns. If you keep on going with the microscope, you will see the same patterns. If you go use a telescope and go up and up, then you can see the same. So that's like many things, like some leaves in the plants, which have this pattern, or some shells in the sea, animals. So a lot of this has some fractal phenomenon. So very interesting and very unique. And So this, we can relegate this to an absolute chance, but that will be a great injustice to the wonderful design, the wonderful creativity that has been brought upon. Whoever made that design. So that will be a very a good argument to bring that. The diversity is there for us to see, and as inherently as humans, we acknowledge this diversity, and we take it for granted. This diversity is part and parcel of life, and we do not want it to be just brushed under the carpet. So similarly, so we have to acknowledge that there is a diversity, and there is also unity. Definitely, nobody is saying no to that. And unity and diversity coexist. That is a very important conclusion that he brings here. And then he goes on to explain that this non-deterministic or diversificatory factors that we see in the world around is actually part of the supreme whole, where he refers to Bhagavad Gita, and he says that this world is nothing but a combination of self, chit, and inert nature, chit, and also a supreme guide and supreme designer, Ishvara. So such chit and Ishvara, these three of them make together this world. And also he quotes from the Isha Upanishad that everything that is created is perfect, is complete in all respects. And even after creating that, the complete material creation, still the Supreme can be complete by himself. And so that is very important to understand. So just like fractals, so fractals on the microscopic level is still a beautiful pattern, while even in the microscopic level, it's still the same beautiful pattern. That is a very interesting observation. Similarly, Supreme Lord, if you were to take him and bring him into this reference frame, then you can possibly explain the absolute chance and the diversity that you see in the world. And that should not be ignored. That possibility should not be ignored. It is his argument. And he also quotes from Brahma Samhita, how that all these universes are created by Govinda, Adi Purusham, Supreme Personality of Godhead. And he is the one who is present in each and every atom in the universe. And so that explains why certain things happen a certain way. Possibly there is a way to explain the causality of all the things that happens in this world. So we have references from the Upanishads and Bhagavad Gita, how the Supreme Absolute at the heart is governing the behavior or the activities of the living and the non-living. So one example is here from the Bhagavad Gita. I'd like to bring here 1861. Supreme Lord is situated in everyone's heart and is directing the wanderings of all living entities, who are seated as if sitting on a machine made of material energy. So that is possibly a supreme whole, which should not be neglected. And that is, he is guiding the wanderings of the living entities. And that's why that gives rise to this diversity. And there is also many other quotes from the Upanishads that Trinam api na charati, even a blade of grass does not move without his sanction. So that is something that is governing how this universe is working at a microscopic level and how the atoms are working at a microscopic level. So possibly that is a good way to harmonize all these different observations. And while emphasizing on unity, someone should also appreciate and acknowledge the diversity, which is definitely a byproduct of this supreme designer. So that was that's what he summarizes here, that one should definitely take some cue from Bhagavad Gita, the Upanishads, and in order to give satisfactory explanation for the non-mechanistic view, and which would be a complete and not just harmonious, but also a comprehensive explanation of the natural phenomena that we see in our day-to-day world. So that's, I believe I rushed through it to some extent, I'm not sure, but I'm not sure. I think I have completed in 40 minutes. I'm not sure if it is too early.
No, never too early. Thank you very much. Do you have any comments or questions? We can open it up now for discussion. It's nice when we have time for that, so thank you. It didn't seem rushed. Okay, so we have Krishna here who's raising her hand. Go ahead.
Yeah,
Krishna.
I always have a question. The thing that popped into my head is, as you're going through this, so we're talking, you know, the mechanistic way, and so one thing causes another, so you have this chain of causal reaction. And then we switched over to the Bhagavad Gita, which no longer is looking at the world in terms of causes. And so my question is, it almost sounds a little bit dualistic, like in order to be in a transcendental type of philosophy, you have to kind of neglect or give up this idea of causality, which is kind of scary, actually. So my question is, I guess, how do we, can we some level of causality in a, when we bring in the Bhagavad Gita, do we have to throw out this whole causal chain, or how does that work? That's
If you don't mind explaining, reiterating the question.
okay. So actually, I wrote this down. You said when, so we're, at the end, you're bringing in the Bhagavad Gita, and the philosophy presented in the Bhagavad Gita, you don't have to account for causality and non-causality of the world. So that's kind of cool. I like that. But then I thought, but I like the mechanistic thing too, because I want to be able to, you know, do things in the world, and I need to have a causal idea that if I do this and that causes this, and then I get this. And so we have, it seems as though we're kind of caught here with a foot in both worlds if you want to actually get by as a conditioned soul. So that's my question, is how do we integrate those two things? Because at this point from this chapter, it seems as though we can either, you know, be transcendental and not worry about causality, or we're stuck in some causal thing where we don't have access to the transcendental.
Yeah, it's a very good point. I mean, that's how the world works. So many of us have some jobs, so we work with an understanding that everything is going to go fine, but we also have some kind of protection for in case of anything that goes wrong. A tree falls on the house, got insurance for the house, and our own health, medical insurance and things like that. So we do cover for the non-causality part of the life, and it's pretty normal for us to kind of take it that this is what I think will happen, but yeah, we possibly get prepared for other things that can happen as well. So I believe that's the philosophy of life that we all have, whether we acknowledge or not, or got used to it.
Well, so what was the punchline?
Could you repeat that last part?
Yeah, so I was saying that there is a lot of different things that happens that we account for in our life, like a medical emergency or anything that could happen that could be could threaten the life and property. So we make an realistic plan to accommodate such non-causal occurrences that can happen in our life. So that is pretty much part of our normal life. So in that way, even in science, more or less the same principle applies here. To a good extent, we can expect things to work in a certain way, which is very aptly explained by different laws of nature, by mathematical and physical laws. But there are a lot of things that is not fully explained, and we need to kind of have some So the Bhagavad Gita offers and makes you a little comfortable. That don't have to worry about all the details that you're not able to understand. Just that, leave it to me. So that is the explanation that Krishna gives in the Bhagavad Gita. So you don't have to be able to accommodate and account for everything that is happening. And I'm telling you that I am the cause of all causes, and behind the screens I am operating. And that explains the non-causality that we see in the world. That's how we have to harmonize things.
Okay, thank you. I think Christina has a comment and then Krishna.
Yeah, I think this is kind of the essence of mental health and being a kind of a well-adjusted person in this world, is to realize that there's always going to be this part, this kind of part of the experience that at least appears causal, and you're like, okay, I do this and then this happens, and then there's going to be a part of the experience which just seems non-causal, and you can either kind of like you interpret that in a way to stress yourself out, like, oh, why can't the non-causal thing be causal, or like, why can't I just sit around doing nothing? Or you can go in the other direction and be like, well, maybe I can kind of make this work for me, and so when something happens that I want to happen, I'd be like, okay, yeah, that's I guess that's the causal part. And then when something happens unexpectedly, you'd be like, oh, okay, nice surprise. So I think how a person kind of interprets and works with those two aspects of reality is pretty influential in just like how you're able to easily move through life, or move through life with more resistance and anxiety.
So does that mean, it sounds to me that kind of implies that whether you take the non-causal part as chance or whether you take it as God, it's irrelevant.
It's irrelevant.
Yeah. So there's, what I'm trying to get at here is.
Well, even the causal chance, you can say it's God or chance.
Yeah.
I mean, because as far as what we define as causal is pretty limited. In one sense, we're imagining we understand the cause.
Yeah.
Because if anything in science, they continually find that there's more to understand about what we thought was the cause. So it's not like this, we have an explanation on certain levels means we understand it. And other stuff that we don't understand means it's not to be understood. It's a little simplistic. I'm not saying anybody's here is doing that, but sometimes it sort of gets boiled down into simplistic terms. If we have an explanation, if we have a word to define it, we must understand it. And if we don't have a word to define it, then it's mysterious and doesn't exist.
So why bring in God? That's what I'm
Well,
trying to get at.
okay,
Let's just add to the equation
Right,
here.
to do science, you don't have to bring in God. Professional science, you don't have to bring in God. But human beings, scientists happen to be human beings, and they have the larger questions.
Right. So chance seems to answer them just as well as God.
Well, to do professional science.
No, but even like Christina said, if I can deal with chance or God, and then I can deal with the causal stuff, you have this mental health thing, whether you call it chance or whether you call it God, doesn't seem to make a difference according to this analysis we have.
There is a slight difference to that. So you can say, I'm an atheist, I don't have to believe that there's anything behind this non-causal things that we see in the world. And you can just relegate it to just pure chance. So we can, for example, a good example that I have given before as well is you got a life and property, you want to protect it. So you can have an insurance, or you can just be completely callous and say, okay, I don't need insurance, just leave it to the God's way. And then, leave it to the chance. Leave it to the chance, anything happens, then, but you know what happens, something might happen. You still have fear component there, in order to which is not accommodated, which is still as something to you have to deal with. So what happens if this happens? That is not something that I want to go through. So obviously, that is definitely some protection that everybody, even an atheist, would seek through. And with all the frailties that material world gives us, that this absolute chance, nobody wants to take a chance with it. So they definitely want to make it more predictable, make it more something that is more that we can deal with, not leave it to complete chance. So you can do that as long as if it's your profession as a scientist. Yes, you can propose different theories, but when it comes to your life, you don't want to leave it absolute chance. So that's if you haven't, so what happens when you bring in Bhagavad Gita, and I would not really extend to any religion for that matter, but when you bring in Bhagavad Gita, I would say that absolute chance, you are trying to make it the non-causal a causal to some extent, because there's a model that the Bhagavad Gita proposes, which explains a lot of different things, which is possibly you can accept. For example, even if Prabhupada calls this always as a science, so that's because this is a model. When you take this model and just look it as a life model of this life, you can possibly explain a lot of different phenomena that's going on. So why some people are born blind, why some people are born lame, why not me, why not him? So all these questions, to some extent, you can reconcile with the reincarnation, karma, different things like that. That gives you a possibly a causal explanation to a non-causal thing. And that's the beauty of it.
Thank you. That's exactly what I wanted to hear, actually. Yeah, that because I'm, anyway. The idea that scientists do use, and this is the problem, I think you hit on it, that scientists are using chance as a cause. That's the problem. And it breaks down pretty quickly, I think. I don't remember in Origins, there's a whole fallacy of absolute chance. I think Sadhgupta describes it a lot more detail, how once you start taking, as you said, something that's non-causal and using it as a cause, and that's what he said, very, very weak. And you just expose that. Thank you.
Hey, Christina.
Yeah, I think this really speaks to how consciousness is really this irreducible aspect of reality, right?
Yes.
So you have Sat, Chit, and Ananda. And so if we just had the Sat and the Chit, then yeah, like things like chance, it wouldn't really matter. But we have the Ananda part, we have this qualitative part, right? The Ananda part, and it means that when something is incorrect, like when it doesn't, it doesn't jibe with our consciousness, then it is in the ultimate sense wrong, because consciousness is fundamental. So there was this psychology experiment, right, where half of the people were given a lecture on how free will exists, and then afterwards they took a questionnaire. Half the people were given a lecture on how free will doesn't exist, and then they took a questionnaire. And the people who were told the free will exists, the questionnaire scores they took a questionnaire before and after the lecture. I think that was probably what it was. So they didn't really change before and after the lecture, whereas the people who were told that free will does not exist, they got noticeably kind of more angry, depressed. They kind of went to, their Ananda went in a bad direction, right? And so what does that tell us, right? If you have this idea that chance is at the bottom of everything, and consciousness is not, then it's that's totally irrational. Like, why, humans are irrational beings. But if you have this idea that if you understand from Bhagavad Gita and other sources maybe that consciousness is fundamental, then that makes a lot of sense. So yeah, I think it really speaks to that aspect of Bhagavad Gita and reality.
Yeah, thank you. I have a question that's more, I guess it's more basic and foundational in regards to this. So for example, when we're hearing from ancient philosophers like Aristotle and Aquinas talking about the natural law, so these laws of nature, for them, I think that there was no separation between God, or there was separation, but they were all kind of lumped together. God, natural laws as it's observed, and the reasoning that we have as humans to observe those laws, which came from God. So my question is, in modern mechanistic science, we can observe laws as opposed to chance, but where do the scientists think that the order of those laws came from? Is that also by chance, or who ordered them in such a precise and perfect way that they are recognized as laws?
That's not a scientific question.
Well, what is it? It's a
It's a
philosophical.
philosophical
Yes,
question.
yeah, I know, but this is the philosophy behind all this. So
Behind all what? No, not necessarily. All the people who established the sort of mechanical perspective on science were all theists.
okay, right. So So you're saying, what about what we're talking about here? These, like you were mentioning statistical law. Where do those concepts come from in the eyes of scientists, if not by a higher consciousness?
Well, scientists are many different kinds of people. So it's not a scientific professional question. So, you know, it's a personal question.
Okay.
I mean, there's always
Maybe I'm
been atheists. Let
maybe
me tell you something. There was
Sure.
plenty of atheists at the time of Aristotle. There was plenty of atheists at the time of
Sure.
Aquinas. They didn't need modern science to be atheists.
Okay, so even then, okay, let's talk about atheists then. Where do natural laws come from? That the ones that we describe in science, if not by a higher conscious
Well,
being?
for us here who are all pious, well, we wouldn't be here.
Well, I'm just asking.
Well,
what's
the natural
current
inclination
understanding?
for the pious is to look to God. You know, for an atheist, they're looking for excuses. He's not there.
If you were a scientist and an atheist, and you're explaining laws of nature.
It's by chance then. That's atheistic.
So even though that's the question, is it a belief
Yep.
that the natural laws, even as ordered as they are coming from chance?
Atheism is a belief because you can't prove it scientifically.
Okay, so that's the answer, that natural laws, even though they're highly structured and ordered and we can observe them as such, they are coming, they kind of sprouted out of nowhere.
Well, that's an atheistic foundational perspective.
Okay,
but,
that's all I wanted to know.
But another thing is, I would add to that, because I don't know how to shut up, is that in science, they shy, from what I understand, they shy away from like laws and universal laws, because like gravity, how do they know gravity works the same throughout this unlimited, they know within their experience, it seems to be consistent. So the tendency now is to shy away from laws as some universal phenomena and so forth. All they can really argue is within our experimental, whatever, this seems to be a consistent pattern.
Okay.
I would also say that like part of the answer is in Prabhu's presentation, is that he's saying that there's this aspect that is you can describe in mathematical formulas like natural laws, right? And then there's the stochastic aspect that is probabilistic. So you might be like, oh, well, but like, where do these natural laws come from? And some other person might be like, okay, well, but look at all this probabilistic kind of noise. Look at all this stuff that looks like chaos. How can, like that's kind of the rejoinder, because both of those elements are always present.
Okay.
You can have, I was in atheistic science for many, many years.
Mm-hmm.
And to me, it was just, if you're going to say consciousness is a fundamental part of reality, you can say these laws are also. That was certainly how I thought of it. They're just a fundamental part of reality.
And
Yeah,
did you ever consider like who put them there?
And why would I think of that?
I don't know.
Okay, again,
Yeah.
that was a belief system.
Yeah.
That was a belief system.
Okay, but that's a
Yeah.
thank you. That's
Right.
not actually.
You don't necessarily need
what
that
I'm getting
belief
to.
system
You
to
don't need
do
it at all.
professional science. But within our generational experience, there has been a class of atheists who have used their concept of material science as a support for a religious worldview or a non-provable worldview.
Hmm,
That's a belief. That's called scientism.
okay. So that was all. Thank you.
Yeah.
From someone who
Who was
one.
one.
Was one. Thank you, Krishna. Do we have any comments or questions? Yes. Go ahead.
Thank you. Thank you,
Pranava, right? Pranada?
Ferdinand. Pranava Das is my name.
Pranavada. So, okay, excuse me, Pranavada. Ferdinand.
Pranavadas Prabhu.
Yeah. I had a question about the foundation, because like in positivism, after in Austria, after the First World War, they started with that there is nothing you can speak about unless it has to do with the senses, something you can see with facts in reality. That's the only thing you can do natural science. So that's one aspect. But then I'm thinking, and I have a question about that too, about the subject, because natural sciences just works about objects, things which are external from us. But we do have subjects as well. We cannot need to define it as even consciousness, but we are looking at things, and the object is outside ourselves, and the subject is within. It's us, basically. That's the essential feature, which, according to natural sciences, is not really there. We cannot even do any research about the subject. We can only study the objects. So I have a question about whether these 2 points of object and subject has come out in natural sciences also. There is an example done in 1920s or 30s, I think. They were looking at the lights and the waves of the light, and depending on who was looking at it, they saw that as a different path. So just an example. Then they start to thinking about, okay, it's not just about the object, we have to think about the subject as well. Just a thought. So my question is whether there is any kind of development in natural sciences that start to include some or other the subject as the main, or one of the elements, not only the objects, but also the subject. That's just a question.
Very, very nice question. Just going by the science aspect of it, so they would not consider you as a subject. I mean, because we are also made up of atoms and DNAs and whatnot. So they think they have plausible explanation for everything that's going in our body. And although they cannot explain, just like how Leela was asking about, how did it happen? Who put in a DNA there? And who said if you have a DNA, if you have these strands in the DNA, it has to come out like this. So where is it all coming from? Where is the science of all that? We have no plausible explanation for that. But still, yes, that part has been to some extent has been considered in the quantum mechanics about the observer being a part of the system and not outside the system, how that can influence the outcome of the experiment. That is definitely considered at that level of quantum mechanics.
Thank you.
We could talk about like
A little point, last point, a little point on the side, completely different. It's about our reality, because we see, for example, natural science is extremely developed. We are living in the 21st century, but politics there in the field, in reality, is a very important thing. And their politics is based on subjects that think differently. And so, but it seems like the two things, the two aspects of objects and subjects are actually very important to understand the complexity that we're living in. Just an example, something to think about. So, but thank you for your reply.
This is good stuff. I'll just add, most scientists aren't that philosophical. When you add this, and this kills me every time. Scientists think. Most scientists don't think about these things. You know, that some do. You know, but most of them.
Krishna said she never considered where it didn't matter.
There are some scientists, exemplary scientists, who are very philosophical, but most scientists, they're doing their experiment. They're really not worried about this stuff.
Well, traditionally,
No. There was no scientists until about 150 years ago. These guys were natural philosophers. They're philosophers. Right. Yes. I mean, again, we're broad brushing this historically. But in our times, there are professional scientists, people doing it as a career. That they do not have.
They didn't know philosophy.
What? No, it depends on the individual. But most of them
Don't.
yes. I mean, I wouldn't count on it. I mean, some of them are there because they're human beings and individuals. But I mean, when we say scientists think this, scientists think that. It's like saying Hare Krishnas think this, Hare Krishnas think that. I mean, you know,
Broad.
yeah, it's a little broad. Be careful with that.
Okay.
but yeah, I just wanted to give a plug for the Global Consciousness Project here. So there's this scientist named Dr. Roger Nelson, and he worked with the PAIR lab, the Princeton Engineering Anomalies Research Lab, back in like the 80s and 90s. And that lab was all about trying to suss out the influence of a conscious agent on mechanical and purely random event generators which were we use electron quantum tunneling in order to like create a truly random result, just like Saraputa's hypothesized random event generator, basically from the presentation. And so the Global Consciousness Project was sort of an outgrowth of the Pear Lab. And he has these random event generators in various places around the world that are just constantly producing these random numbers. And he looks at and the data all gets synchronized in this like server. And then he looks at the data in certain intervals around events that affect mass consciousness. So for example, New Year's Eve, or like really big tragedies like September 11th, or, Princess Diana's funeral, or, big things like that. And he's done a really amazing amount of research to show and analysis to show that there is a small, but definitely a statistically significant effect of consciousness on the numbers being shifted away from the stream of numbers basically being shifted away from what they would expect from pure chance. So I definitely recommend checking that out.
Thank you. It's what the BI is reading now. Yeah, thank you. Any other questions, comments, concerns? Okay,
Hi,
Krishna? Oh,
can
hi.
I chip in?
Yes,
Hi,
please do. Welcome.
So first of all, my name is Guido. I'm in Chile, but I'm a faculty here in engineering. And actually, I got my PhD from Georgia Tech, where Narasimha studied too. So
That's
anyway,
kind of close to
I don't want to. Sorry.
You're almost,
So-
you should come down here, the Georgia Tech, that's not that far from here.
Yeah,
Only
yeah,
Yeah.
yeah. No, but I'm in Chile.
Now you
South
are, but you
America.
were at Georgia Tech before.
the end of the world.
Yeah.
Anyways,
yeah.
don't mind, don't mind.
Yeah. So anyways, I don't want to ask a question, just wanted to make a comment, or actually like many comments. So regarding the topic of causality, probability, actually in probability, there's this philosophical discussion on what's actually probability theory, because the mathematical theory is very consistent, is rounded up, but it doesn't match with like the real world. Like there are many phenomena that, or it isn't actually describing like human perception of chances. So it's a philosophical discussion, because then what's really probability? Then also I wanted to regarding statistics, these statistics tests, there's also all this discussion on frequencies and Bayesian statistics, on like what are we really trying to measure here. So frequency statistics, they're just saying, you know what, it's just frequencies of events. And Bayesian statistics is about like your belief on the chance of a given event. So that too is a philosophical discussion. It's like a ongoing, never-ending war between Bayesian and frequencies. So that too. And also random number generation. So I saw some years ago a talk about from I think it's maybe a mathematician. He's in the Advanced Institute for Advanced Studies in Princeton, talking about the random number generation and the fact that it's extremely difficult to do that, extremely difficult, like from the computational point of view, and certifying that a sequence that you are outputting, that's actually random, that's extremely difficult, a very big problem in computation. Yeah, that too, that came to my mind. And finally, this is more like an esoteric comment. So we know that astrology falls within this framework, this theology, this religion, whatever you want to call it. And I actually believe in astrology. I've made my charts, and it's really amazing. Like even its predictive power. To me, it's amazing. I've also recently, a friend had this tarot. I don't know how it's called, tarot. So same thing. It's just so it's super powerful. And I know that there are therapies that they look at your illnesses from your eye, your iris, also from your hands, and so on. So it's so the same issue about like a chance, like how is it possible that the positioning of these huge celestial objects can somehow say something about you, this particular point. So that big picture somehow saying something about the macroscopic, saying something about the microscopic. Also, the microscopic, your iris, that's a very small thing on your body, also saying something about your whole body, your hand, also, and also somehow saying something about your destiny. Or also the tarot. So that's they shuffle the cards. So that should be then it should be random. And actually that's been studied. Like you need like 3 shuffles to make it like a random. So it's completely random, but somehow it comes to say something about your life, your destiny, whatever. So that's really amazing. And maybe a reflection I've had is like, okay, so maybe how can that shuffle somehow be there? There's going to be an order that's going to correlate with your life, with the questions that you are posing, and so on. So this is very like just a mental concoction of mine. So I think it's got to be like with this how is it called, these subtle beings somehow being there and telling you something. So and they get in the way of this shuffleness, and I don't know. It's so there are many layers there, and from my point of view, and this theology provides all these like layers that can help into giving an explanation, a theory, like a possible explanation of this phenomenon. So yeah,
Well,
I just wanted to make all those comments.
Well, good luck mathematically quantifying that.
What was your name, Prabhu? I didn't hear.
Guido.
My name is
Guido.
Guido. Yes, Guido.
Guido.
G-U-I-D.
It's right there on the screen.
Yeah, thank you.
Yeah.
That's a very interesting.
Oh.
Yeah, I think you just put randomness on the stand. So yeah, because they appear random, but you know, those of us who have experienced that,
Yeah.
it's not so random.
Hey, so I made a joke.
Exactly.
Good luck mathematically quantifying that. I made that as
Yeah,
a joke.
sure.
But just the fact that you can mathematically quantify so much is a big philosophical question in itself.
Yeah.
And then turn it around again. And if you then there's like a belief that if you can't mathematically quantify it, it can't be real.
Yeah.
How are you going to prove that? You know, so we got to be careful. Sometimes we have these reference points and we bump against them, and you know, and we artificially limit the conversation.
Yeah.
I really like your observations, and I just want what it sparked for me is that we also it also points to the role of interpretation and subjectivity in interpreting the quantifiable data and relaying it to, let's say, you, and you interpreting that as, you know, as applying to your life, right? So in the case of tarot cards, but it could work for any of these examples. there's always some room for interpretation, right? Different astrologers will maybe or different tarot card readers will kind of like interpret the cards in slightly different ways and say like, okay, well, maybe this is what's going on for you. And then also your interpretation of what they say, like, oh, yes, that's correct for me because of this, this, and this going on in my life. That's also a function of like your consciousness and your subjectivity and what's going on for you at the time. So I think it's really interesting to think about that aspect as well.
We actually have a Jyotish scholar here. Nartaka, is there anything you'd like to add to this?
Unmute.
No, you'll have to unmute yourself.
Hey, we
Yes,
can't hear you.
Nasrina
She's
Devi-
talking. She's trying to talk.
No, she thinks she's trying to unmute. We can't hear you. You're muted.
You got to push the button.
Okay, sorry.
Yeah, there you go. Thank you.
Yeah, no, sorry, there's nothing I would like to add, but thank you very much for the wonderful presentation today.
No, thank you. Thank you for being here. And Nasrina Dev, you had a comment?
Yeah, just talking on the probability theory and the statistical process. So it has different application in science and engineering, for example. So in science, it tells you, it quantifies how much you can explain, how much you cannot explain, unlimited chance. But in engineering, it helps you to kind of address certain problems that can possibly happen. And for example, you are doing a satellite communication, you're sending some digital data to the satellite. So there's always going to be some information that will be lost. And you can quantify and you can say there's a good probability that you may have 30% of information lost. So you're going to add additional, if you can say, redundant information in order to recover back that lost information. So that helps to quantify, okay, there's 30% chance you may lose this. So add this extra 10% to kind of recover the information so that you still have the right information. So that helps in kind of tackling certain challenges. And in life also, so we always, when we look at, okay, you are on a flood plain, what is the likelihood of your house getting flooded? So you're going to add more insurance and apply for more comprehensive insurance, for example. So yes, that helps us to kind of take some decisions in life and engineering. But in science, yes, it doesn't have. It only leaves you with more questions to wonder about.
Great, thank you. Okay, very nice discussion. Thank you very much again for taking the time to come and explain this chapter to us and answer all the questions. Thank you all for your comments. Very enlivening discussion, and there's more. We can always just keep going on and on. So we will meet again in 2 weeks on May 13th. The presentation is chapter 7. It's our 8th lecture, and it's the chapter on inspiration. That's the name of it, given by Christopher Beadle, Krishna Kripadas. He received a BA in computer science from Brown University and assisted Richard L. Thompson, Sariputta in the production of his books and videos on science and Krishna consciousness for 17 years. He now travels to promote the public congregational chanting of the Hare Krishna Mahamantra. And he teaches classes. He serves as a Krishna.com live help volunteer and is a proofreader for the Back to Godhead magazine. And he's been working with the BIHS since its inception in 2015. So we're very excited to hear from him in 2 weeks. Also, for tomorrow, we have another program at 10 a.m. Eastern Time, Leaps of Faith and Doubt by Pracharananda Das. That is 10 a.m. We can send the link is on our website. Also goes into some of these topics of science and philosophy. So we hope to see you there. Otherwise, we will see you in 2 weeks, and go to our YouTube channel for any prior lectures. Thank you very much. And see you again. Thank you again, Narasimhadeva. Much appreciated. Have a great weekend, everyone.
Hare Krishna.
Hare Krishna.
Well,